So we calculate our bandwidth and the slew rate calculation. So bandwidth formula is to use the equation. This is bandwidth. So this is a 0.35 divided by right side. So this is the equation to calculate the bandwidth. And also we can also calculate the output voltage. Output voltage. So to calculate the output voltage, we can calculate formula. This is voltage gain divided by 2 multiply with input voltage. So this is the input voltage as of P to P. So voltage gain input voltage is a P to P. So for the input voltage P to P, you have to use the voltage gain 5 and 2. But input voltage is only the half is given, so you have to utilize the time. So this is formula. Another one will be the change in the output voltage. Percentage change in output voltage. So this is for the percentage 2 minus percentage 1 multiply with the output voltage. So then we see the rising voltage. Can be calculated. So this is percentage change output voltage multiply with output is equal to rising voltage. And then you can also calculate the slew rate. The slew rate formula is the rising voltage divided by right side increase to new value. Rise in voltage divided by the right side increase to new value. So this is for the we can calculate the slew rate. That's our output voltage respond to the input. And these are change in the input can affect the output change. So this is the rate of change, the rate of the response. The rate of the response for the input output to respond the input change. This is the slew rate. The slew rate you can calculate. So in this case of bandwidth is 0.35 by the right side. Output voltage, any change in the input voltage can affect the output voltage. So input voltage percentage change affect the output voltage. We can also calculate. The slew rate change also we can calculate. Slew rate is the rise in the voltage divided by right side increase to the new value. This is the slew rate we can calculate. Another one formula is a gain bandwidth product. Gain bandwidth product is this is the GBWP. This is the gain bandwidth product. So gain bandwidth product formula is voltage gain divided to multiply with the bandwidth. So this is the formula. And also the right side due to slew rate. So when the slew rate happens, so the right side will also be changing. So this is the right side due to slew rate. So this formula is, so this is the percentage 2 minus percentage 1 multiply with gain divided to multiply with input voltage VI divided by slew rate. It is equation. And also the new right side you can also calculate. New right side. So this formula is 0.35 divided by GBWP, gain bandwidth product divided by gain. So those things are we can calculate by the equation. This problem a non-inverting amplifier has a voltage gain 20. So input voltage at 10 volts are minimum P2P. So that's the square weight. So 10% to 90% right side is the right side for the 3.5 microsecond. So when the voltage is input voltage increase to 1 volt, the output is at 10% increase to 90%, and right side also increase to 12.8 microsecond. So we have to calculate the small signal bandwidth. So first is we have to calculate small signal bandwidth. Bandwidth is equal to 0.35 divided by right side. So this is 0.35 divided by right side. The right side is at 33.5 microsecond. So this will be substitute 3.5 microsecond. So 10 power minus 6. So by solving this one, we got the thing is this will be the 100 kilo. 100 into 100,000. So that will be the 100 kilohertz. So bandwidth is the 100 kilohertz we calculate. So this is the first question, first answer. And another thing that we also have to calculate some slew rate. So when to calculate slew rate? The slew rate equation is the rise in voltage divided by right side increase to the new value. So this is for the slew rate we can calculate. So this is for the slew rate equation is rise in voltage divided by right side increase to the new value. So right side increase to new value is at 12.8 microsecond, and we also have to calculate the rise in voltage. So we substitute the equation. This is a slew rate. The equation is the rise in voltage. Divided by right side increase to new value. Okay, rise in voltage we can calculate. So rise in voltage means that percentage 2. So this is second condition percentage and first condition percentage multiplied with the output voltage. So this is the rise in voltage. So this equation we can calculate percentage 2 minus percentage 1 multiplied with output voltage. Divided by right side increase to new value is 12.8 microsecond. So this one we can calculate. So in this case, output voltage we also calculate. Output voltage is the voltage gain by 2 divided by input voltage P2P. So this is we can. So in this case, we have to find the output voltage. Percentage 2 is the already calculated. This is at 90%. Percentage 1 is at 10%. So this is 90% minus 10%. Percentage 2 is 90%. And percentage 1 will be the percentage 2 is second condition percentage. Percentage 1 is first condition percentage. This is a 10%. So this one you can calculate. And we have to find the output voltage so that you can calculate the slew rate. So we have to find the output voltage. So output voltage we are already given the formula. Output voltage is equal to voltage gain by 2 multiply input voltage P2P. So this formula we can utilize. So this is voltage gain by 2 multiply with input voltage P2P. So this is the so voltage gain by 2. The voltage gain already given here. Voltage gain is 20. So this is 20 by 2. Multiply with the input voltage P2P. The P2P input voltage. So if the P2P input voltage is already given, this is the 10 millivolt P2P. So this is we substitute as and we substitute equation here. So by substitute the voltage gain divided by 2. So this is the input voltage P2P. The whole thing is done. So percentage 2 is at 90 minus percentage 1 is 10. Multiply the output voltage. So output voltage is equal to this is for the 20 to 10 into 10 into 10 power minus 3 and divided by the 12.8 into 10 power minus 6. Then you can calculate the slew rate. So this is the slew rate. The slew rate you can calculate the 0.625 volt per microsecond. So 0.625 into 10 power minus 6 volt per second or 0.625 volt per microsecond. So we can calculate that. So this is for the we can calculate the slew rate. It's a 0.625 volt per microsecond. Another one is the key where to calculate the gain bandwidth product. So this is the GBWB, gain bandwidth product. So the formula is gain bandwidth product you can calculate. So gain bandwidth product is a voltage gain by 2 multiplies the bandwidth. So this formula. Multiply with the bandwidth. Okay, so this equation, so voltage gain by 2. So voltage gain is 20 by 2 multiplied bandwidth. So bandwidth you can calculate. Bandwidth is 100 kilohertz. So 100 kilohertz you can calculate. So 100 kilohertz. So this becomes 10 multiplied 100 kilohertz. So that will be the 1000 kilohertz. So this becomes 1 megahertz. So gain bandwidth product is a 1 megahertz we calculate. And the C, so the gain bandwidth product of the amplifier. So this is the C we already calculate, gain bandwidth product of the amplifier. And the D, so we have to calculate the P to B square wave voltage. So voltage is the right side is 10% to the 90%, and slew rate is equal to 10% to 90% right side. So we have to calculate the new signal right side if the gain is adjusted to the 5 by 5. So I find you to slew rate. So right side due to slew rate can be calculated. So this equation is the percentage 2 minus the percentage 1 multiplied with the K by 2 multiplied with VI divided by slew rate. So this is the equation. So this becomes percentage 2 minus percentage 1 and multiplying with the K divided by 2 multiplied with VI and divided by slew rate. So then the percentage 2 is at 90 and percentage 1 is at 10. Multiply gain divided by 2, so gain is at 20 by 2. So input voltage VI. So VI value is already given that this one is this is a VI and divided by slew rate. Slew rate we already calculate. The slew rate is 0.625. 0.625 is a microsecond. So this is for the then. So this will be calculated. So this is the right hand due to the slew rate. Right hand due to the slew rate is a 3 by 5 microsecond. Then you have to calculate the VI. From here we can calculate. So right hand due to the slew rate already given here. In the program, the right side due to the slew rate is a 3 by 5 microsecond. Then you can calculate the right side. Input voltage. So this is the equation of this is a 3 by 5. So 3.5 is equal to AC multiply 10 multiply VI divided by 0.625. Otherwise, there's a new small signal right side is a gain adjusted to the 5 by 5. So we have to calculate for the E. New small signal right side is a gain adjusted to the 5 by 5. So new right side is a 0.35 divided by gain bandwidth, then we product divided by gain. So this is equation. So the new right side. Can be calculated. So this becomes 0.35 GB WB divided by K. So this is 0.35. So gain bandwidth product. So gain bandwidth product is we already calculated 1 megahertz. Here we already calculate gain bandwidth product. It's at 1 megahertz. So this is a 10 power 6. 1 megahertz divided by the K. K is already given the 5 by 5. So that way we get 0.35 into 1 into 10 power 6 divided by 5.5. So then we saw the gain bandwidth we get 1.9 microseconds. So this is the final answer. So after this we talk about the operational amplifier. So analog 1 is after this stage we use the operational amplifier. So those are in the analog circuit up to this stage. This is the we already see the original operational amplifier. This is the general characteristic. So DJ characteristic I have already given you in the H025. H025 has been finished in the first half of the semester. So in this case give you the operational amplifier IC. But here is the general characteristic of the operational amplifier. So in the next up to the week 17, I do another book. So the more detail about the analog circuit. Okay, after this stage we make the summarizing. First is the frequency response. Magnitude and the frequency response of the amplifier that decrease with the frequency. So this is the first thing. So this is for the we use the summary. So the magnitude of frequency response of the operational amplifier in the open loop decrease with the frequency, and the phase shift gets more negative due to the sway capacitance in the device. So that this frequency amplifier got the operational amplifier got the sway capacitance. Both the sway capacitance are decrease the magnitude and the phase shift. So this is the phase margin. So phase signal less than the minus 180 degree and amplifier becomes unstable. So phase signal phase. The signal phase is less than or equal to minus 180 degrees. So amplifier is unstable and oscillate. So because of this one, if you want to maintain the stable operation of the amplifier, the phase signal phase must be greater than the minus 180 degree. And when the phase margin 45 degree, in this case the bandwidth decrease and square wave time increase. So the phase margin about 45 degree. So what will happen is so this frequency response is nearly flat. Frequency response is flat, nearly flat. So phase margin is about 45 degrees. The frequency response is nearly flat. And so for the stable amplifier, 3 dB is the cut-off frequency for stable amplifier. Three dB is cut-off frequency. So cut-off frequency means that high pass and a low pass are changing. So when there's a high pass amplifier, as well as you reach at a 3 dB, and then it allows us to pass through that high frequency. But for the low pass amplifier, as well as it reaches at 3 dB, it will cut off the frequency. So this 3 dB is a cut-off frequency. So another method will be that we have to use the compensation. We have to use the compensation. We have to stabilize the amplifier, negative feedback amplifier. So negative feedback amplifier, to make the stabilization, we have to reduce the high frequency gain. So to stabilize. And FE, so negative feedback. Amplifier. So reduce the signal gain. And another one will be the frequency compensation. So frequency compensation also need to be utilized to stabilize the negative feedback amplifier. So this is for the frequency and compensation. It's utilized to stabilize the negative feedback amplifier. And also we also use a frequency compensation method. So this is for the frequency compensation is utilized to stabilize the negative feedback amplifier. So we use the frequency compensation method. That will be the feed-forward or single capacitor, two capacitor feed-forward method. Single capacitor, two capacitor. And a feed-forward. The voltage you can calculate. So the gain bandwidth blocker and slew rates are inversely related to the value of the compensation capacitor. So in this another relationship, gain bandwidth blocker. So this is the inversely proportional to value of compensation capacitor. And also the slew rate. The inversely proportional to value of compensation capacitor. So one word. So those are the characteristics of the operational amplifier. So due to the phase capacitance, magnitude, frequency response, overloop decrease with the frequency and signal phase less than the 180 degree, amplifier can be the unstable. So when the phase margin above the 45 degree, so frequency response is flat. So to gain a stable amplifier, so we have to use the 3 dB as a cut-off frequency. To stabilize the negative feedback amplifier, we have to reduce the signal gain. So frequency compensation is utilized to stabilize the negative feedback amplifier. So especially the single capacitor, two capacitor, feed-forward capacitor are utilized. So gain bandwidth product is inversely proportional to the value of compensation capacitor. Similarly, slew rate is also inversely proportional to the value of the compensation capacitor. So those are the aspects. So when we are making the amplifier circuit, operational amplifier circuit, the important one is the stabilization. So those are stabilization. Stabilization, we use the compensation capacitor, we use the appropriate cut-off frequency, we do not allow the signal phase to be smaller than the 100 minus 180 degree. So all then we have to use. So because of this one, we have to use the conversion capacitor. Then we use the single capacitor or two capacitor or 3-for-1 capacitor. So these are we utilize to stabilize the operational amplifier. So this section is